So now, now that we have all the language and terminologies to describe our devices and things about our devices, let's start looking into how we would deploy this in a oneM2M architecture. So we'll start off with the structure for a sensor device. And a sensor device, that's one of the devices that is just doing the measuring of a value. And all of our devices have to register as an entity. So they all do a create AE and register the device itself, and along with the appropriate oneM2M AE attributes, such as the name of the device and the request reachability and so forth. And then for each sensor type that our devices have, we will have a container that holds the measurement values or the data that is being measured. So there will be a container, and the measurement values will be placed into content instances that will target that container resource. Also, for a light device has the common aspect where it's going to have to do the AE registration, but also our lampposts will also have the ability to not only tell us the status of the light, whether it is on or off, but it'll also have a way to allow an external interface to turn the device or command the device on or off. And for our applications here, what we need to know is what to write to the resource, to that command resource, in order to turn the device on or off. Do we write a 1? Do we write an on, or any other versions of on or off that the device may support, or how it was defined? And then also for that command container, we want to create a subscription. And what this subscription does is allow for the CSE to notify the device whenever a command value has been received. It'll send a notification with the content instance, in that notification, so that the device will receive the command and then take an appropriate action, and then also update the status back in the CSE, once the appropriate action has been taken. The smart device is a combination of both of those. So the smart device has both the data containers, a container for each sensor type that we are going to measure for that particular smart device, and then also the status of the light and the command container, so that remote entities can control whether the light is on or off. So in order to realize that architecture, what I wanted to do is build a device simulator for that. And what you see here is a wireframe description of that device simulator. And and this is a GUI representation of that. A lot of times our simulations do not need a GUI. You can do it completely without it, and it's actually significantly easier. But from a demonstration and a visibility and kind of going through the development process, a GUI type application does have some benefits. So what I'm showing here is my original ideas for how to build this device simulator. And what I wanted to have was, a section for each type of sensor. And in that sensor type, I would allow an edit box where I can type in a value that would represent the device, the measurement that that device would be taking at that particular time. And then I also wanted to have a button that would send the value once I've finished putting it into the edit box. Also, for the lights, I wanted to be able to send a light status to the CSE whenever we change it. So the idea here is if I click the button, I'm going to change the state of the light. And then I'm also using this icon to reflect the status of the light. So when I click it, I want the button to show an on value or an off value in some fashion. A couple tips that are that I found useful for demonstrating or building this kind of architecture is to model a system like this and get the call flows working in a simulation, and then you can port them to actual devices. And what this allows is one, you make sure that all the call flows work well, and then two, it also gives the applications on the front end, the user applications, a way to model the system, without having actual devices, to work with. They can test those front end applications using these device simulators, and it's a good method for the design and development of a system like this. One thing that I've learned over the years of implementing these kinds of simulations is it is good to have these register and deregister buttons and the quit button on our devices. It's helpful for doing debugging, because if that call flow doesn't work the very first time, you'll wind up going through this process a couple times. So I'm going to, a little bit later, I'll go into some of the details of the code for the simulation, but I wanted to provide some of the background information, in the slide set here. For this particular device simulator, I'm using for my GUI interface, I'm using PySimple GUI as the library. My entire simulation is written in Python, and for the GUI, it's PySimple GUI. I have a few libraries that I'm including in order to find a couple files in my on my device, and this next section is basically some include files that are necessary to change those button icons and modify them at runtime, and load them from file. And also, because I'm simulating a device, and I don't want to create a separate device or separate set of code for every type device configuration that we have. What I did was created a configuration for each device. So my simulator code is one file that models the device, and then with a configuration file, I can specify all the parameters that are appropriate for that particular device. So all the devices that we saw in our use case scenario will be able to specify through the configuration file. There's, I'll have to send some HTTP requests, and I chose to use JSON for the payload this time. If you remember in the first presentation or part one of this tutorial, I was using XML. This time I'm using JSON just to do something different. And then also, because some of these devices are listening for notifications. Those are considered actuators. They're listening for notifications of when a command is sent to change the state of the light. I needed an HTTP server, and then also I needed to put that into a separate thread so that I can handle the GUI processing and my separate notifications separately. And then also I just have the time here because for one of the resources, I just have it periodically updating one of the sensor values. And that's just to add a little bit of activity into the system. So this is the call flows that the device simulation code will have to execute. On the left, we have the startup code that will have to be run. And what's happening here is that when the device starts up, it has to do a few basic things to set up for its steady state operations. For example, all entities in oneM2M have to register. They do that by sending a create AE primitive. Next, for each sensor type that our device is simulating, it will create a container for every single one of them. And that container is where it will send its measurements to through a content instance. After we create the containers for the sensor types, we go ahead and set up for the light operations if the device is a light. And in this case, it's going to create two containers. One container will be for holding the current state of the light, whether it's on or off. And another container will be a command container, and that will be where external entities can send a command to control this device to turn its light on or off. And in order to do that, this device has to subscribe to that command container, so it does a create subscription primitive for that. In the center, I have the steady state operations for the device simulation. When one of the buttons of the sensors are pushed or the sensor timer fires, then this simulates a new sample of the sensor type or a new measurement. And that measurement is sent to the oneM2M CSE in a create content instance resource. Also, for the device, whenever a command is received from the CSE, i.e. a command to turn the light on or off, that will come through a notification request. That notification request will be received by the device. Then the device will have to respond to it. And at that point, the device will change the state according to the command that was in that particular message. Once it changes the state, it then reflects its new state with a create content instance primitive that is sent to the status container that the device created. And then the device, whenever it's shutting down, should shut down properly and deregister, and that occurs with a delete AE primitive that I show on the right. So now that I've talked about the device simulator, I want to bring us back to our scenario of devices in our deployment. And in particular, what I want to highlight here is, the devices that are lights versus meters versus the sensor values of luminance, phosphorescence, and light absorption. And then also here we have some of the other information that we wanted in our semantic descriptors with the last maintenance time and the light color. So all of this will be used in order to enhance our model of our device with the semantics. So the question becomes, from a deployment perspective, when am I going to put all these semantic descriptors into the CSE, and and what entities are going to do that? And One option could have been to, just put all of our semantic triples into one semantic description resource. That would have kind of been similar to what we did in part one when I was doing the demonstrations to highlight the values of semantic discovery and the semantic queries. But what I believe is that's not really representative of how it would be done in a deployment. I think in a deployment, there are certain things that the device itself could specify in semantic descriptors when the device is starting up and running, but there's also some information that the device would not be aware of when it's being programmed or designed at front, such that these semantic descriptors have to be done at a later time. An example of those would be the locations, for example. The device, when we're building the device in the factory, it doesn't have any idea of where it's actually going to be placed, right? So in the models that we have here in this deployment, I'm separating some of the information and separating the semantic descriptors into parts and putting them into different semantic descriptor resources. Also, some of the questions that we talked about, for example, how do I turn a light on, or what type of, how do I read the sensor value from a particular device? Those are things that the device may or may not know when it's being created. It could have, it could have a pretty good idea, but it may not be aware of it, back, when it's being developed in the factory. So I'm gonna show how some of these things are done in the simulation, and what you'll see here is, for some of the oneM2M ontology specific things, like the oneM2M target URI or the oneM2M URI value, those are placed into semantic descriptors when a container is created. There are some semantic descriptors that are, populated when the device turns on, and there are some semantic descriptors that are done completely separately and from a different application, and that's what I have highlighted here in green. So this is another view of our RDF triples, and what I'm highlighting here is a little bit about what I talked about on the previous slide and the type of information that is going to be created by which entities. In green is the entity that is, or are the RDF triples that will be created and populated by a different application. And in my example, it'll be the deployment application that will specify where a particular device is located. In red, I have things that are, what the device does, and what it is, what it does, and some of the properties, things that the device can know, when it's shipped, and it has the ability to populate these things out of the box. Now at the bottom here, we have a slightly different case. It's the device doesn't know all of this information when it, until it's deployed, but once the device does start creating the containers, it does have this information available. So what you'll see, for example, at the bottom, how to access this device in oneM2M, the things that it does know, at the start is what its data restrictions are, what the oneM2M method is, but it does not know what the oneM2M target URI is. It will not know that until the container for a particular device is already created. In this case, for a light command, not until that container is created can we populate this. So the way that I do that is after creating the application entity, the create AE, the response that comes back with a resource ID that the application will capture. And then in my configuration file, which I'm showing here on the right, this is the payload of a semantic descriptor resource, describing a particular device. And what you'll see is, each of these devices has this oneM2M target URI that I populated with just a keyword, the resource ID keyword. And after AE create has completed and I get the resource ID, I just do a replace operation on resource ID with the actual resource ID that is returned in the create AE response. So a similar type of thing occurs for the sensors. And after going through all the semantic triples of the sensors, I saw things became a little bit simpler once you start putting it into place. The oneM2M portion of it and the data restrictions and the method, this is the same for all of the sensors. Even the light status sensor has this same sensor payload. So I'm able to, in my configuration file, specify this value. And then when the simulation device is running, again, when that particular container is created, it's just a replace operation on the resource ID, and then the appropriate triples are used in the creation of the semantic descriptor. And it's only slightly different for the light. The part that's the same is the light status payload at the bottom. That is actually the same as a sensor payload. I could actually just use the same value there. On the top, we have the command payloads, and this one is a little bit different because what we're describing here is instead of how to read a sensor value, we're describing how to command the light on. And in this example, we have two different commands that the light can take. It has an on state and an off state. And in the on state, well, in both cases, it's a create method. And in oneM2M, if the ontology, if the oneM2M method is a create, in our standard, it says that the create applies to a content instance resource. There's also an attribute where we could specify, or there's an ontology term that we could specify an attribute. And when we include an attribute in this definition, then what we're talking about is doing an update to a flex container resource and the particular attribute of that flex container resource definition. Also, in the semantic descriptors that we have here, we have the data descriptions for the particular device. Well, what I'm showing here is the value on and the value off in order to turn the device on and off. And these are of particular importance because if you don't use these data restrictions, the device will not recognize the command given, and it'll just ignore it.